Today we are looking at a question in NECO GCSE, and it happens to be moment of equilibrium and under mechanics. So we are going to answer each of these questions in our various videos, but today we answer question 12A. And the question says a uniform beam PQ of length 8 meters and mass 12 kilograms is supported horizontally at the end of P and at the point arrow 3 meters from Q. A boy of mass 30 kilograms walk along the beam starting from P. If the beam is in equilibrium, calculate the reaction of P and arrow when he walked 2.5 meters. So remember, we got to say the distance he walked when the two reactions are equal. And question 3, the distance he walked before the beam tips over. We are given G as 10 meters per second square. So let's see how we can tackle this question. First of all, you need to understand the concept of a moment. Moment is defined as the period of force and its perpendicular distance to a point of action. That is the definition of a moment. So let me illustrate with a simple diagram before we actually tackle the question. If I have a beam such as this, and I have a support at this point, and I have a force here, let's call it F. Let's call where the support is as O. And the force is always perpendicular to the distance. Let's call the distance from here to here as D. So what is now the moment? The moment is the force to the point of action, which is product of force and distance. That is what we call moments. Therefore, the moment at O will give us F times D, which is FD. So this is the concept of looking for a moment of a force about a point. This point this time is point O. So with that in mind, let's tackle the question. So it says the beam is PQ. Let's draw the beam now. Let's assume this is the beam. I will label it P and Q. And the distance is 8 meters for the beam. Let's go back to the question. Say the beam has a mass of 12 kilograms. The mass of this beam will act on the center of gravity of the beam, which is 4 meters. Center of gravity of a rectangular bar is the total distance divided by 2. So the mass will rest on the center of gravity, which is 4 meters. But we are working with weight, not mass. So I will convert this mass to weight. As we all know, weight is mg. Weight is mg. So if I multiply 12 by 10, that will give us 120 Newton as the weight. So at 4 meters, I will have the weight of the object at that point, which is 120 Newton. Then we also told that the beam is supported horizontally at the end P and at a point R 3 meters from Q. So we have a support at P and we have a support at R, but R is 3 meters from Q. So let's fix that. Then we have a support here at P and we have a support at R. And that R is 3 meters from Q. Yeah, the distance between both of them is now 3 meters. Then you say a boy of mass 30 kilograms, which is 300 Newton. I'll convert the mass to weight, 300 Newton, walk along the beam starting from P. So if the beam is in equilibrium, calculate the reaction at P and R when the boy walked 2.5 meters. So the mass of 30 kilograms now, the mass of 30 kilograms walk for 2.5 meters along the beam. So let's illustrate that in the diagram. So the boy walked 2.5 meters. So let's take from here to here as my 2.5 meters. The weight now will be 300 Newton. Now we are asked to find the reaction at P and Q. So at this point, I will have a reaction. Let's call it reaction P. At this point, we have a reaction. Let's call it reaction R. So we have conditions for equilibrium. One of the conditions for equilibrium is that total upward force must be equal to total downward force. So what are the upward force? We have RP plus R is equals to, the downward force is 300 and 120 is equals to 300 plus 120. So we're having RP plus R, that will give us 420 Newton. So let's classify this as equation 1. So before you take the moment, it's important you get the distance of each force to the support. So for the 300, distance from the 300 to the support P is 2.5. So here's 2.5, that means distance from here to here will be 1.5 meter. And the distance from here to here will be 1 meter. So with this in mind, now we cannot take moment. So it's your choice where you want to take the moment, because we have two support here. We have support P and support R. So you have to determine whether you have to take the moment as support P or you have to take the moment as support Q. It's your choice to make. So let's take it at R. Let's take the moment at point R. So meaning all the force should come to R. It should come to R. Meaning 120 will go to R, 300 will go to R, and the reaction at P will also go to R. So the reaction at R is acting at its own point, so there will be no moment at that point. So all the forces are heading to R. With that, let's take the moment. I will now classify, I will say sum of moment at R is equals to 0. Sum of moment at R equals to 0. So, as you know, moment is force times distance. So what is the distance of this force to R? Distance of 120 to R is 1 meter. Distance of 300 to R is 2.5 meter. And distance of RP to R is simply 5 meters. So let's take a moment at R. So we're going to have 120 times 1, 300 times 2.5. So let's do that. We're going to have, okay, before you do that, we need to consider the concept of clockwise and anti-clockwise. If I have a system like this is clockwise, it's going in the opposite side, this is anti-clockwise. So you can see the 120 is anti-clockwise, the 300 is anti-clockwise, while your RP is clockwise. So for the anti-clockwise, there will be a negative value, while the clockwise will be a positive value. So with that in mind, let's see what we have. Minus 120 times 1 plus minus 300 times, what's the distance? Distance of 300 is 2.5. So we're having 2.5 plus RP times 5 is equals to 0. So this is the concept of clockwise and anti-clockwise. So I'm having minus 120 minus 300 times of 2.5, that will give us 750 plus 5 RP is equals to 0. So if I add 120 to 750, that will give us a minus 870 plus 5 RP is equals to 0. So if I make 5 RP the subject formula, I will have 5 RP is equals to 0 plus 870. That's equals to 870. So my RP is simply 870 divided by 5. That will give us 174 Newton. This is not the reaction at P. So we are also asked to find the reaction at Q. So let's go back to our first statement. So from equation 1, we have that RP plus RR is 420. So let's recall that expression for us to find our RR. So I will say RP plus RR is simply 420 Newton. So we've gotten our RP as 174. So if I fix it, I'm having 174 plus RR, that will give us 420. So my RR, reaction at R is now 420 minus 174. That will give us 420 minus 174, that will give us a 246 Newton. So that's answered question 1, Roman figure 1 of the question. So next is to find question to Roman figure 2. It says calculate the distance it walk when the two reactions are equal. From what we've done, we've got to the two reactions as 246 and 174. But this time around, those two values are different. This time around, they are asking us if the two reactions are equal. What's the distance the boy walked? So that means I need to redraw a different diagram for Roman figure 2. So Roman figure 2, I'm going to have the first system now. There is a support here. There is a support here, which is at point R. This is Q, 8 meters, while this is P. So the reactions are equal now. That means here will be reaction R, no longer reaction P. Because you say reactions are equal, here is now reaction R. So at equilibrium, at the center of gravity, we have the force of let me go back to it, of 120 Newton. Now the force of 120 Newton. Then they're not asking us the distance the boy walked. So for now, we don't know the distance he walked. So I'll call the distance the boy walked to be X meter. I don't know. And the weight of the boy is 300 Newton. I don't know the distance the boy walked. So let's call it X. So we are told from here to here is 3 meters. That means from here to here is 1 meter. Okay. So what is if the reactions are equal, what is their values? What is the value of the two reactions? It simply means that my RP is equals to RR. The value is what is R. Two reactions are equal. So what are their values? So we're still going to apply the same principles of moment. Total upward force equals to total downward force. So what are the upward force? R plus R. What are the downward force? 300 plus 120. So this one implies 2R is equals to 420. So my R is simply 420 divided by 2. That will give us 210 Newton. So each of the reaction is now 210. With that in mind, let's take our moment. Let's take moment at point P this time. Let's take moment at point P, meaning this one is coming to P, this one is coming to P, this one is going to P. So let's take moment at point P. So I will say sum of moment at P is equals to 0. Don't forget our clockwise and anti-clockwise. So it's going clockwise. This one is not clockwise, our arrow is anti-clockwise. So I'm going to have 300 times X, then also We're going to have 300 times x plus 120 times 4 minus 210, which value of the arrow now, times 5 is equals to 0. So if I simplify what I have, here will give us 300x plus 480 minus 210 times 5, that will give us 1050 is equals to 0. So if I add up, I can add these two guys together because they are the same values. They don't have variable x. So I'm having 300x minus 480. That will give us minus 570 is equals to 0. So to find x, I will collect like terms. I'm having 300x is equals to 0 plus 570, which is anything as 570. So my s is simply 570 divided by 300. That will give us 1.9 meter. So the boy walked 1.9 meter from the beginning, which is from P. That is the distance the boy walked according to question 2. Question Roman figure 2. The distance he walked when two reactions are equal. It means that the boy walked a distance of 1.9 meter from P, because they say the distance, the boy started walking from P. So he walked 1.9 meter from P. The Roman figure 3, the distance he walked before the beam tips over. So to solve this question, I'll first of all illustrate it with a diagram practically and see why it is so. So if you have a beam of this nature, according to the question, I have a support here and I have a support here. And a man started walking from P. He's walking to this direction. So immediately he walked past these supports, maybe the guy is not here. There's no doubt this beam will tip over in this manner. It becomes this. You will now have a situation like this. Because at this point, the support will now move from P. The beam will now tip over at this point. So how do we illustrate it according to the question? So to illustrate that, I will redraw the first diagram this time around again. So I'm going to have, here is P, Q, as usual. Here is R. Then there is a support here at P. That's now reaction P. There is support here at R. That's now reaction R. So the weight of the beam is at 4. So the put is at CG, and that weight is 120 Newton. So for the beam to tip over, the boy must walk past this reaction. So let's say the boy walked to this point with a weight of 300 Newton. So the distance he walked now, we don't know, let's call it y this time. Let's call it y meter. The distance the boy walked this time, let's call it y meter from P. So if you look very well, we are told that from P to R is 3 meters. That means from the CG to R will be 1 meter. So what is the point? From P to R is now 5 meters. And from P to where the 300 is Y. What is the distance from P to where the boy is now? Let me call this one B, the boy now. So distance from there will be Y minus 5 meters. Will give us Y minus 5 meters. So if the distance from P to R is 5 meters, and the distance from P to where the boy is 300, which is Y meter, which is 300 meters is Y meter. The distance from the boy to R will be Y minus 5. So from this point, I can now take my moment at R by having clockwise, anti-clockwise. clockwise. So if that should happen, which is clockwise now is the 300 and the anti-clockwise is the 120. I'm going to have 300 times y minus 5 is equals to 120 times what? Times 1. 120 times 1. If I expand, that will give me 300y minus 1500 equals to 120. Collect like terms, I'm having 300y equals to 120 plus 1500. If you add up, we're going to have 120 plus 1500. That will give us 1620. So my y is simply 1620 divided by 300, which will give us what? Give us a 5.4, which is a very perfect result. A very perfect result. So that is the distance the boy will walk before the beam tips over. It's a very perfect solution, because before the beam tips over, according to the diagram I illustrated, the boy must walk past arrow, and from P to arrow is 5 meters. That means he walked 5.4 meters before the beam will tip over. This is a perfect solution. This is STEM of Africa. If you like what you are doing, please press the subscribe button, like, and comment. Thank you. See you in our next class. To answer question B of it, to answer question B of the question. With that one is also under mechanics, but involves which is this question now? Question B involve differentiation. I will explain it in our next class. We are asked to find the force. Thank you. See you in our next video.